So I'm going to turn you over to Roop Saini, who's going to be walking you through the iModel schema. Roop, over to you.
Thank you, Jason. I'm going to share my screen. Okay, good morning, everyone. Afternoon, evening, depending on where you are. So I wanted to start today's session with, we got some feedback, as Jason mentioned. Some people said that iModel.js is a technology stack and they don't know the prereqs for starting. There's React knowledge required and TypeScript, and you might not know what all you need, and we didn't cover that in introduction. So I just want to, real quick, I want to guide you to a resource. Just go to medium.com/iModel.js. You'll see this blog post, hop on board. You click on that, scroll down, you will see all the prereqs you need and videos linking up to those resources. As it suggests, it helps you build a foundation of where you can get started and actually start looking into some code yourself. And there's code walkthroughs and also links to the showcase that we saw yesterday. So please give that a look if you're interested or if you need that background. And while I'm here, one more thing I want to talk about is we have this blog post, Road to IoT, and that we got a couple questions about iModel.js and IoT. So I do want to mention this is a project we did with Microsoft. It was a collaboration, and you'll see that we have a demo here of the app. It's a quick demo, and it just talks about what is possible when you bring together IoT and iModel.js. And there's going to be sample code for this. It's going to be open source soon, and also a link from Microsoft video that walks through how you would do it yourself. So yeah, that is my shameless plug of the day. Once again, medium.com/iModel.js. Okay, so with that, we are ready to talk about data. So let's go ahead and I'll open up a notepad, and we will, so when it comes to data, as a developer, you have your application and you want to pull in your data. And when you think about pulling in data as a developer, you think of writing queries. You want to write some sort of query so that you can extract the specific data you need. So there's this whole step of writing queries. But in order to do that, you need to first understand how the data is structured, how the schemas are defined, and you need that knowledge. So you need to be able to explore and understand your schemas. And what's cool is that we have a tool for both these things, for writing queries and exploring schemas. And we're going to walk through both these tools, and we're going to do that by taking an example of what we call cross-probing. This was the first project that I worked on when I had to write queries, and got a lot of tabs open here. Okay, this is the one. So what this is it's an application that cross-probes between 3D and 2D models. So I can click on an element here in the 3D model, and it pops open the 2D model for that and zooms into that 2D element. And I can do that for any element that has that link from 3D to 2D. And I can do the same thing on the other end. I can click on a 2D element, and then I can go back. So what we're going to do this morning is we will look at how we will actually write this query together step by step, and I will explain the process that goes behind writing iModel.js queries. So when it comes to understanding these schemas, I briefly mentioned this yesterday, but infrastructure is just a huge problem. There are all these different domains. There's plant, electrical, civil, and all these different domains and applications have their own way of structuring data and have their own schemas. And that's a pretty big problem to solve. So the way we have solved it here with iModel.js is we have these schemas. We call them the biz schemas. And these are standardized schemas that define some standards that are going to be consistent across iModels. And that's where you can begin to start querying your data. So you don't have to understand every plant schema or every application schema, all those data sources that Jason just showed you. You don't have to understand all the data behind that. All you need to know is biz, and from there you can start exploring the schemas for an advanced application, such as a plant application. In this case, we're looking at a plant. All these tabs. Okay, so this is a plant. So this is a plant domain that we're working with. Okay, so when it comes to exploring through biz, there are two things that you're looking for. One is you want to be able to find elements, and you can do that by finding the class of an element. That is, if I click on a 3D element or 2D element, those elements, what are their classes? For example, for our 3D element, we have geometric element 3D, that's the class. For our 2D element, it's geometric element 2D. once you figured out those elements, if you know what these elements are and these elements are, now you want to figure out how they're connected. So you can click on one and then get to the other. So that step involves finding relationships. So you want to be able to find relationships between these elements to do anything useful and to actually start fulfilling your use cases with these schemas. And that's our task here. In order to accomplish cross-probing, we need to find that relationship between 2D and 3D. That's my OCD right there. Okay, so we're gonna go ahead and then look into these tools. So first we will go to writing queries, and that is the iModel console. Now this lets you write queries against your iModel, and then you can play around with your schemas, with your data, and figure out the exact contents that you need. And you can plug that query that you end up with in your iModel.js app to extract the data and fulfill your use case. Over here, if you go the top right here, click on this dial, you have this option for Schema Explorer, and that's the exploration tool for discovering the different schemas and building an understanding of how this data is structured. So let's give this a moment. So this is I think it's a rather dramatic message. All it's saying is that there's no schema currently selected. So these are the schemas that we have on the left. So you see BizCore to generic. These schemas, I want to point them out. These are all the standard basic biz schemas that you'll find in almost every iModel. If you build an understanding for these, then that's like the key thing you need to start understanding these advanced schemas, such as these plan schemas that you see here. And then there's a search bar for searching for any of the classes and discovering the contents of these schemas. So we talked about the geometric element 3D as an example. So we click on that, and that pops open this tab, and it gives details on this class. So it's for the BizCore schema, and the class name is geometric element 3D. And these are all the properties for this particular class. And you can see these data types and their descriptions to try to understand what this class contains. So let's go ahead and see what sort of 3D elements this iModel has. And this is the same iModel that we saw here that has the plant. Okay, so let's do select. Oh, by the way, the queries, when it comes to writing, this language is EC SQL, and this is very close to, it's based on SQL. So you can use a lot of your SQL knowledge to start querying iModel.js or iModel data already. So we'll do a select star from, now in relational databases, usually you query from a table, and the way you define a table, or you can look up a table in EC SQL, is you type in the schema name and the class name. Press enter, and that gives us a list of all the 3D elements in this iModel. So we can see we have 3,600. Now let's repeat this process for 2D. So we'll look for geometric element 2D, and this is our 2D class. So this is our 2D class. We'll copy this. And you don't have to write the whole schema name, by the way. If you click on the schema, you see these aliases. These are shorthands, because some of these schema names can get really long. So you can use this alias to look up your schema. So you can do select star from biz.paste in that class name. And that gives us all the 2D elements in this iModel. So we have the 3D elements and we have the 2D elements. And now we can start investigating how they are related. So where do you begin this investigation? If you're looking at a particular element, as we saw here, we were clicking on these elements. Where would you start actually thinking of, hey, what is this particular element, or these elements, what are they? So the way you can do that is you can log element IDs, and I'll share the code snippet for that. So I can click on this element as an example, and it logs this element ID. And what this is the EC instance ID. That's the unique ID for this element. And every element within the iModel is going to have a unique EC instance ID. It's your primary key, essentially. So we'll copy this. And let's see what this class is in our console. So select star from biz.element. You can query this class, by the way, to search for any element within the iModel, where EC instance ID is equal to, paste that in, and that gives us the details on this particular element, and we can see the plant class type for this is shell and tube heat exchanger. So let's copy that, paste that into our Schema Explorer because we want to understand what exactly this means, this class. And you click here, and you can see the class. This is the advanced plant class for this element. Now, you might be like, hey, what is going on over here? We just talked about 3D elements, and there's this completely new, scary little class here. What is this about? So the way schemas are structured in Biz, and this is a key tenet for Biz, is that all these advanced schemas are based on these base schemas, and that's going to be true for any iModel. So similarly, the classes, for example, this plant class, is going to be based on some of these base classes, and we keep building classes on top of other classes. And you can see that right here. When you look at the properties, you can see these plant property types. But if you scroll up to the top, you can see geometric element 3D. So it's got those 3D element properties as well. And that's the key advice I have for you is always go back to Biz. So anytime you find an advanced class type, you go up the hierarchy, there's the tree structure, and find the base element in Biz that it inherits from. So you have the heat exchanger, we have equipment, this is a device, a named item, plan-based object, physical element, and we have our geometric element 3D right here. So let's go ahead and take a screenshot of this. So we're not worried about the plant classes in this case, so we're just going to stick to this section right here. Copy that, we'll go on to Paint. That's my favorite Microsoft application. After Notepad, of course, and we paste that here, and this is our 3D hierarchy. Now we can repeat this for 2D. So let's go back to our investigation app here, and we can go ahead and switch to a drawing model. So these are all the drawing models in this iModel. So let's go with this thing right here. It looks like it's looking to be clicked on, and here is the element ID for this element. Let's copy that, go back to our console. We'll do a select star from biz.element, and biz.element is the base class for every class in the iModel, and that's why you can use it to query any element. Where EC instance ID is equal to, paste that in. And okay, so when you see this message, that just means that the session has expired, and all you have to do is hit refresh. And we will disable this, we don't need that. And we'll do that again, select start from biz.element where EC instance ID is equal to, paste that. And you can see that this is a PNID graphic, PID graphic type. So let's copy that and start investigating this. So PID graphic, click on this, and again, you can see over here the hierarchy. So PID graphic goes to drawing graphic, that goes to graphical element 2D, which goes to our geometric element 2D, and that's what we talked about. Okay, so let's take a screenshot of this as well. Let's do 2D to, let's again get some of these biz classes. This is good. Let's paste that here. Move this up a bit, and let's add some tags so we know what these are. So this is our 3D, and this is our 2D. Okay, so now we have the hierarchies for these elements, so we kind of understand how this data is structured, and this is a good first step to understanding elements. And now we're ready to talk about relationships. So now let's see how these 2D and 3D elements are related. I have way too many tabs here. Let's kill some of these. Okay. All right, so where would we begin that? Let's actually go to the Biz documentation. And I recommend this, that you check this out. There's a bunch of articles here, and this talks about the foundation of Biz, the Biz universe, and how it was designed. So I recommend going into this documentation. We'll look into relationship for now. There are 4 different relationship types in Biz, and the one we're going to focus on is the element refers to elements relationship in this case, because we have a 2D element that refers to a 3D element or back. We don't know yet how that's connected, but there's one element referring to another. So that's what we're going to look into. The key thing to understand here is that relationships also have their own classes. Just as these elements have classes, relationships also have classes. So let's go ahead and look for all the relationships that refer to from one element to another in this model. Select star from biz.paste.in. And this gives us all the relationships in this iModel where one element refers to another. Now, the main thing here that I want you guys to focus on is there's a source EC instance ID and target EC instance ID. The source EC instance ID is where the relationship is coming from, and target is where it's going towards. So for example, if let's say 3D was connected to 2D and source could potentially be 3D and the target could be 2D, we don't know that yet. So this just identifies those individual elements that are linked together. And you can see to the left, just as we saw in the 2D and 3D element case, there are these specialized classes for the element refers to element relationship as well, and that's true for relationships. So for the sake of understanding this hierarchy, let's do the same thing here. So you can see this is the hierarchy for all the different types of element refers to element relationships. And there's a bunch here. There's all these plant relationships. Again, in this case, we're just worried about biz. So let's go with these classes. Hop over to Paint. And these are our candidates for the relationships between these elements. So we can start investigating these now. Again, it's always best to start from a single element because there's so much information here, right? You don't want to guess around and not know what you're looking for. So we'll just pick an element to find the relationship for. So let's go with that 2D element that we saw earlier. We had logged the EC instance ID for this. So let's copy. Go back to our console. Now we'll do a select. By the way, you can press up to get the same statement, the last statement that you did, and you can do that for the history of your statements. So we'll do biz element refers to element where. Now it could either be the target or source. Something is pointing to it or it's pointing towards something. So let's try to see if it's a target. Target EC instance ID is equal to, paste that in, and no results found. So it's not a target. So let's see maybe if it's the source. Source EC instance ID is equal to that EC instance ID, and there is a relationship from this element to a target. And you can see over here, the name of the relationship is drawing graphic represents functional element. This is the source, and this is the target. So, and for just a reference, this is the one that we're looking at. Let me color this up. Drawing graphic represents functional element, and it's an element refers to element relationship, as we discussed. I can do a better line. There you go. Now we have to figure out what is this target element that it's pointing to. So let's go ahead and do the same thing. Select star from biz.element. That's where we look for our elements. So let's see what the EC instance ID is. So this is a tower. So what is a tower? Again, go back to the Schema Explorer, paste that in. So tower is a process functional schema. So as always, we go back to biz. So we're gonna go up the hierarchy to understand this better. And we see this is a role element, which is a functional element. So let's go ahead and take a screenshot of this. So it's not as easy as we thought. It's not directly linked to a 3D element. There's this functional element in the middle. So let's go ahead and paste that here. So this is our functional element type. Let's type that here. Functional. Okay. And what we've discovered so far is that there's this 2D element that refers to this functional element. Now the question, and it does that through this relationship, drawing graphic represents functional element. The question is there maybe a functional to 3D connection that we can find? So that's what we'll search for next. So let's go ahead and go back to our investigation tool, and we will go to spatial. We go to open the 3D model. I could just use that element that we logged earlier, but let's log a fresh one. Let's click on this thing, copy that, and we will go again back to the console and same thing. Select star from biz.element refers to elements. to see if it refers to anything, where source EC instance ID is equal to, paste that in. So it has a connection, and the target EC instance ID is this one. So again, let's find out what that is. Paste that, and it's process functional vessel. So I bet this goes to functional. Let's see, vessel. We have pfunc, we have equipment, named item, plan-based object, function element, role element. So we can see that connection. We have that 3D element that refers to our function element as well. So we go back to our paint. So we found this relationship from functional to 3D. So we can go from 2D to functional. We can go from functional to 3D. Now the question is, can we directly go from 3D to 2D and get this all in one nice query? So for that, we will have to do a join. We can just join both these queries that we came up with. So so let's go ahead and take a look at these relationships. We have drawing graphic represents function element, and the physical relationship is physical element fulfills function. So let's mark that here. Okay, now what we can do is we can get a list of all the relationships for all the links from the drawing to functional and the physical to functional. So let's search for that. So we can again use the Schema Explorer for defining these queries. So drawing graphic represents function element. This is 2D to functional. Copy that, get a list of all these. So we'll do select star from, paste that in, and that gives us everything that goes from 2D to functional. Now we'll do the same with physical element fulfills function. So we'll copy this. And we will, again, do select star from, paste that in, and that gives us all the 3D to functional. Now we have 2D to functional, 3D to functional, and we just need to link both these queries up. So for that, we can just do a join. So let's copy that, and we'll copy this one too, and we'll start doing some joins. And again, this is generic SQL. You would do join as you would do in SQL, and there's a tutorial on this, the EC SQL tutorial, that can kind of guide you on how you would do it with EC SQL. So I'll post a link to that. I'll post a link to that at the end as well. So let's go ahead and join this. So we're going to select star from physical to functional. Now we need to give this table an alias. So let's call that physical to functional. And we join it with this one, and we'll call it drawing to functional. And then on, how are we joining these two tables? Now we want the functional elements on both these tables to match up. So we'll make sure that the target EC instance IDs for both these link together. So we'll do the relationship on that. Let me do a lowercase physical here so it matches this one. Physical to functional dot target EC instance ID is equal to drawing to functional dot target EC instance ID. Press enter, and that gives us all the relationships. Now this ginormous table contains all the instance IDs for the 3D elements that are linked to the 2D elements. Now we're almost there. We have almost fulfilled our case for cross-probing. Now, if you look at our tool here, now you can see from all these views, there's one 3D view, and there are multiple drawing views. And that's usually how it is. You have one, in an iModel, you would typically have one 3D model and multiple drawing models. So we don't know which drawing model a 2D model belongs to. So if I click on this, I don't know which of these I need to pop open before I zoom into that 2D element. So we need to find the model for that 2D element, and that's the last task to fulfill our cross-probing. So for that, if you can see the relationships, there's a relationship called model contains elements. Now, the way elements are categorized or structured in iModels is a list of elements that are within a certain model, as you saw, a 3D model or a 2D model, and each element is going to have a model ID. So let's go ahead and go back to our console, and we look at just some 2D elements. Select star from biz.geometric element 2D. And over here, you can see the property. So we have model ID. So this is the model ID we need. And this gives us that distinct reference to that drawing we can pop open, and before we zoom into that 2D element. So now we're almost there. We just need to join this information with that join we did earlier. So let's go up, get that statement, and we'll join another table on top of this. Just going back to our reference, just to explain what's going on here. We have this 2D element, and we found that geometric element 2D, and this has a model, and we want to be able to open that model. So we're going to join it with our statements for our relationships that we joined earlier. So over here, we'll go back and let's see, select star. We'll go to the end of this, and we'll do a join. And this is going to be biz.geometric element 2D dot, and we got to give this a name, an alias. So let's call this let's call it the drawing element. And then do the join on. Now, what are we joining again? So we want these EC instance IDs for these 2D elements. Where'd it go? These EC instance IDs to match up with the source and the drawing graphic represents functional elements. So with this drawing graphic, we want to match up with this geometric element, as drawing graphic belongs to that geometric element. So that's where we're joining. So let's go back to the end of this. And on, let's do drawing element dot EC instance ID is equal to, we had the drawing to functional dot, that it was the source was the drawing element, source EC instance ID. And hopefully I typed that right, press enter, and it works. Great. So now we have all the information we need. We have the model, we have the 2D elements and the 3D elements that are linked together. But we have a little too much information. Imagine parsing this in your app. That would be a lot of work. So let's clean this up a bit. We'll just get the information that we need. So what all do we need? We need the physical, the 3D element ID. So physical to functional, and that was the 3D element ID is the source in that. So dot source EC instance ID. And we will call this our element 3D. And then we need our drawing, the 2D element ID, so drawing to functional dot source EC instance ID as, let's call this element 2D. And then we need our model for that 2D element, so we can pop that open when we zoom into it. So for that, we have our drawing element dot model dot ID as model 2D. So hope I got that right. Okay, cool. So this is all the information we need for cross probing. So we found 167 links between 2D and 3D. So we have these 3D elements, so we can click on a 3D element and then pop open the model for that 2D element and zoom into that 2D element. We can click on any 2D element and pop open to or zoom into the corresponding 3D element. And that fulfills our use case for cross probing. I mentioned a bunch of different links that you could use for reference. Now, again, we'll go back to the blog, Medium iModel.js. There's this post, ablabiz. And you'll find these links in the resources if you scroll to the bottom. And this has a list of all the resources you need. So you'll see these links here. So the console, the EasySQL tutorial, how to log your element IDs for investigating specific elements. The sample iModel that I used in the sample, you can find that too. BizDocs and how you would do that join. And there's also videos of the same presentation I gave, but a more polished version of it that you can watch again in case I lost you anywhere. And it is a lot of subject matter, so I would give it a couple of watches and give some time for the info to soak in. Okay. So one thing that we haven't talked about is there were a couple more relationships here. And I just want to briefly, this is the last thing I'll do, is just talk about the ones that we missed. Element owns child elements, and element owns unique aspect or multi-aspects. we already talked about models, so that's covered. So what this is, it's a relationship where you could have an element that is composed of other elements, and this is just a way of organizing that hierarchy of, I'll just give you an example. So let's just look this up in our console. We'll do select star from biz.paste that in, and you can see over here, these are, these are the element-owned child element relationships. So for example, you can see over here, pipe has segment. So pipe is broken up into several segments. So this classifies that. So you can find that relationship. If you have a pipe segment or you're trying to look for the parent element, you can traverse this relationship. And the other relationship that's left is the element owns aspects. It could be unique or multi-aspect. Now what this is, aspects are basically a set of properties. And they're kind of like these dangling properties that could be useful for any class. So they're kind of generic, and they can be applied to a bunch of different classes. So instead of putting those properties in every class, what we can do is we can just create a relationship between those, the aspect, the reusable properties, with the other class types. And we'll look at an example for that as well. So I have an iModel open here. So let's do .ecsql. This is a hotkey, by the way, for some pre-prepared queries that you can use. And the one we're going to look at is provenance. Again, we saw that message again, so we're going to refresh. And I need to sign in because this is a private tab. Close, pop that open, and .ecsql, provenance. And you can see this relationship here. So is external source aspect. This is a kind of aspect, source aspect. And what this is, so yesterday we talked about how all these different design programs and files, you're mapping all this information into an iModel. And just now we talked about how there are these unique IDs, the EC instance ID, for every element within the iModel. But what if you find an element and you want to figure out what was the ID in the source element? How would you backtrack? And that's what this provenance schema and this external source aspect is for. So let's take the example of, let's just copy this. And this is going to be very quick. I'm about to wrap up. So we have from join biz dot, let's do a spatial element. And then we will just get all the information from this query. Again, you can reproduce this query by pressing .ecsql and getting these pre-canned ones. We'll do star. And so this gives us a bunch of aspects. Now you can see the instance IDs of these elements. And if I scroll to the right, you can see these identifiers. So these are the identifiers in the original authoring application if you need to backtrack. And then you also have a checksum. If you want to keep track of any elements that have changed, you can see if the checksum value has changed, and that can help you keep track of change. So that wraps up all the heavy topics I had for this session. The last thing I will mention here, and I promise this is the last, is we have these schemas. So we saw the biz schemas, which I would say that these are the ones you should focus on when you first learn about these schemas. And then you have these plan schemas. And the query we came up with here that took us from 3D to 2D and back, these are based on all the biz classes as we saw here. These are all fundamental biz classes. So what that means potentially is that you could use this same query in some other infrastructure domain. So this was plant, you could use it in some other domain. And as long as those 3D to 2D connections are mapped in, you can use the exact same statements to traverse your data and go from 3D to 2D. Now, that's going to require some bridging and some bridge development, but the technology has the capacity to do that. And that's a big reason why the iModel was conceived as the standard for data for the infrastructure digital twin, because it can take all these different infrastructure domains and unify it in the standard foundational set of schemas. Okay, so that wraps up this session. In the next one, you will hear from Bill, who is a core developer with iModel.js, and he's got an awesome demo prepped up for you guys at the end of his presentation, so please stay tuned for that. And with that, I'll hand it back to you, Jason.